Hi everyone, myself Dr. Lakshmi Prasad, working as a professor in the Department of Computer Science and Engineering in Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about the basics of graph representation and its types. So the very first thing is that, definition. So graph is nothing but a generalization of the simple concepts of set of dots, what we call it as edges or arcs. And normally this graph is going to be represented in the form of G sets v comma e, where v should be the set of vertices and g should be set of edges here. So one thing I would like to say that the graph should be a collection of points or nodes, whatever it is, and this thing node should be represented as a nodes and vertices, and these dots are going to be connected by means of a line, what we call it as an edges or arcs, and this what we call it as points are nodes and vertices. So the graph should be a collection of vertex set and then edge set. Okay. So in this one, so what I'm going to say, these are the edges E1, E2, E3, E4, E5, E6, E7, D8. So the vertex may be of V1, V2 up to so on V7, and edges may be. So normally the edges will be of different types. So what I say that is directed edge and undirected edge. So directed edge is nothing but ordered pair of vertices which should be represented as UV, where directed from vertex U to V. And undirected edge means that it should be represented as UV. So in this one, what I'm going to say this is it should be where the edge may not have the direction, so that's why it should be called as a undirected edge here. And next one is that loop. So loop is nothing but edge, so where the endpoints are equal here, that is the edge joining the vertex to itself is called a loop, and this should be represented as u comma u. So whenever I'm going to take a vertex here, so the edge whatever is there, that should be going same to the same vertex a. So the edge is going to be same, which is going to be self joining itself, is called a loop here. And multiple edges means that so whenever the node is going to have two types of edges, then I can able to say that the node is going to have a multiple edges. So that means that the edges which is going to be joining with the same pair of vertices. And simple graph, so simple graph is nothing but a V and then non-empty set of vertices and the edge set E, so where E should be unordered pair of distinct elements of V. And so this one what we called as G of V comma E, so V should be the set of vertices and E should be set of edges here. So that should be represented as vertex that should be represented as UVW, and edge that should be represented as UVVW and then UW. So multi-graph means that it should be consist of set of vertices and set of edges, and if there is a function from E to U, then the edges which is going to have multiple edges or parallel edges, so that thing what we called as a multi-graph. So a graph which is going to hold self loops and then multiple edges in between the pair of vertices, then I can able to say that should be a multi-graph here. So whenever the graph does not have any kind of multiple edges in graph, then that should think what we called as a simple graph. and there should be multi-graph. Since this graph is going to have multiple or parallel edges in between them, so that's why it should be called as a multiple graph. And the graph which is going to hold only one vertex, one edge, so that thing what we called as a simple graph. And next one is the pseudograph. The pseudograph G consists of set of vertices and edges, and the function from E to a set of edges. So this one represented as E1, E2, and then E3 and E4. So the pseudograph, normal graph should be same here. There is nothing different between the normal graph and then pseudographs. Where in this one the loops are going to be allowed. That is the only difference. So in normal graphs, we are going to not allow any kind of loops in between them. And so whenever the graph which is going to hold the multiple edges and then self loop, so this one what we called as a pseudograph. So one is simple graph and there is multiple graph, that means multiple edges is going to hold. And similarly, if the graph is going to be hold both the multiple edges and self loop, then it will what we called as pseudograph. And here the directed edge. So what is the directed graph? So a graph which is going to hold directed edges, then that a graph what we called as a directed graph. So the graph which is going to hold edges, so then I can able to call it as a directed graph here. So whenever the graph does not hold any kind of directed edges, then it should be undirected graphs. So a directed graph is nothing but set of vertices and edges which is going to be joined by the directed edges. And directed multigraph. So graph is said to be directed multigraph. So whenever the multigraph is going to hold the multiple edges, multiple directed edges, then I can able to say that should be the directed multigraph. So whenever I'm going to consider a graph which is going to have set of vertices and edges, and these edges are said to be multiple edges. So when I'm going to take a vertex at u comma v, in between that I'm going to hold two types of edges, e1 and then e2. So let me explain the difference between the different types of graphs and then how this is going to be different from other graph. So in simple graph, we have undirected edges, no multiple edges, no loops. So in simple graph, so the edges may be undirected one and does not contain any self loops and then multiple edges. This graph what we called as a simple graph. Multi-graph is also have undirected edges, so it is possible to have multiple edges and then the loops also not possible. And pseudograph means that, so this should be a multi-graph. Along with the multi-graph, if the node is going to have the self loop, then what we call as the pseudograph. And directed graph means that the edge is going to hold the directed edges and no multiple edges is going to be held in between them. Then I can able to say the loops also going to be allowed or should be directional one, then it should be directed graphs. So directed multi-graph means that, so in this one if I'm going to hold the multiple edges and if I'm going to hold loops, then I can able to say this should be the directed multi-graph. And next one, terminology. So what should be the undirected graph here? The vertices U and V are adjacent if and only if the E is incident to with U and then U and V, and U and V are the endpoints. The degree of the vertex should be equal to the number of edges incident on the vertex, and then loop contributes twice the degree. So the pendant vertex, so that is nothing but degree of V equal to 1. Isolated vertex is nothing but degree of K equal to 0. So whenever the vertex is going to hold, so whenever the degree of the vertex is 1, so that thing what we called as a pendant vertex. And whenever the degree of the vertex is equal to 0, that means no, then it should be isolated a vertex here. And degree of the vertex is the number of edges that are incident on the vertex, should be the degree of the vertex, and then the loop contributes twice or more degree. So this should be the directed graph. So UVW should be the vertices, and the edges set is this one. So whenever what is the degree of U and V? So the degree of U is 2 and V is 1 and V is 1. So the K is isolated because there is no edge between one vertex to another vertex. The next one is that directed graph. So for each edge, you come up with adjacent. So in degree means that the number of edges which are for which you use the terminal vertex, and number of edges for which you should be the initial vertex. In degree means that so the number of vertices that should be reflect to the vertex should be considered as in degree, and then whenever the edge that is leaving from the vertex, that should be called as out degree. So handshaking theorem. So according to handshaking theorem, so the number of edges it should be degree of V bar divided by 2. So that should be the handshaking theorem. So another theorem is that so undirected graph has even number of vertices with odd degree. So whenever the undirected graph is considered, it is going to have even number of vertices and is having with the odd degree. So let's V1 be the set of even degree vertices and V2 should be the odd degree vertices. So 2E is equal to this one, and finally I'm going to calculate degree of U is equal to, sorry, degree of V is equal to degree of U plus degree of V. So the sum of the last two terms on that right side of that inequality is even. So whenever the sum value is 2E, and second term should be defined as degree of U is equal to V. And some of the special cases of the graphs. So is a complete simple graph that contains exactly one edge between them for every pair of vertices, then it should be a complete graph. So whenever there is a vertex, there should be for every pair of vertices there should be an edge connected between them. Suppose if I'm going to consider the two vertices, this should be the one edge. If I'm going to consider so for every pair of vertices there is an edge between them. And if I'm going to consider four vertex, so this should be the fully connected, so that's why it should be a complete graph, and this may not become called as complete graph. Simple graphs are nothing but the special cases, consists of n vertices and edges is this. So representation, how can able to represent this cycle graph? So there exists a cycle with three vertices, that's why it should be C3 and then C4. And then weights is going to be obtained by adding a vertex to Cn and then connecting all the vertices to the new vertex by new edges. So whenever I'm going to consider this, so connecting all the vertices is possible. And similarly, if I'm going to consider the 4, then we also have been able to connect all the vertices. of that node. The n cube is nothing but the vertices represented by 2-bit strings of length n. So here the two vertices are adjacent depend only if the bit strings that they represent differ by exactly one position. So here the q1 and q2 are two graphs I'm going to consider. So the q1, the vertices represented by n bit should be represented of length n. So here the two vertices are adjacent if and only if the bit string that should be able to represent exactly one bit position. The next one is a bipartite graph. So what is bipartite graph? So normally in simple graph, if we partition into two or more sets, then every edge of the graph connects to the other two vertices. So if I'm going to consider a set of v1, v2, v3, and this should be the set of number v2, v4, and then v4, v5, and then v6. So whenever there should be exist a path between the two vertices, then I can able to see there should be the example of bipartite graph. Complete registration. So complete bipartite graph. So here the KMN is the graph that has a vertex set partitioned into two sets, and there is an edge between the two vertices if and only if the vertices is the first subset and other is the second subset. So whenever I'm going to consider a vertex set, then I can write it as 2, 3. That means that an edge that is going to have it, the edge set is not going to have this subgraph of the graph G is equal to this. So where V dash is the subset of V and E dash should be subset of V. So by applying this, this should be the vertices of this graph. So when I'm going to consider, so the entire thing should be also be subgraph of this. So this should be subgraph of this, and this should be also the subgraph of this. So I graph U1, G1 and G2. So where E2 and E2 equal to E1 union E2, and then V equal to V1 union V2, and here G1, G2, G3 are the simple graphs of the graph. So when I'm going to consider a vertex graph, so UW, WV, and then UWV. So everything should be the subgraph of the given graph. Next one is that representation. So in this one, two types of representation is going to allow incident matrix and adjacency matrix. So the most useful form when the information is going to be about the edges is more desirable than about vertices. And adjacency list is that most useful when the information about the vertices is more desirable. And these two vertices are almost popular since the information about the vertices is often before the desirable. Next one, we are going to represent the adjacency matrix here. So here, if I'm going to consider a matrix, so consider the vertices of where graph among the x axis and y axis. So whenever there exists an edge between them, so I can represent it as v comma e. Ones and zeros, so whenever there exists an edge between them, otherwise it should be 0. So next one is representation. So adjacency matrix and adjacency list. So whenever I'm going to consider a node, so what are the adjacent color that are connected? If I'm going to consider a node U, then adjacency list will be V comma W, and V it should be U comma W, and W should be X comma Y. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.